Good afternoon, everybody. We are dealing with the topic nucleophilic addition of the carbonyl compounds and addition of nucleophiles to the carbonyl group. Now, carbonyl group is actually this group which is present in the aldehydes, ketones, diketones, etc. Now, we need to know two things. First is the nature or the structure of the C-double mono group, and second is how it is been added. And what are nucleophiles? Nucleophiles are those species which are negatively charged or which may have excess or ample amount of electrons to just react with those having positive species or positive charges, whatever. So we are coming to this. Nucleophiles means they have a tendency to react with the positive species or positively charged substances. So whatever, we try to understand the carbonyl group. So this is the structure of the carbonyl group. You see, this carbon is actually sp2 hybridized, and these angles are 120 degrees. So the structure is a trigonal planar. Suppose there are two groups A and B. Now since oxygen is electronegative, so this is we put here delta minus and we put here delta plus because carbon is comparatively electropositive. Here oxygen will have a tendency to pull off the electron pairs of the bonds towards itself, hence rendering a slight negatively charged on itself. Now if you try to see the nature of this group, this also have an ionic structure like this. If this bond is like this, so you can write this like this also. So carbon is positive, oxygen is negative. So this is another structure. If you try to put the electrons, the Lewis based nature, then you can put it like this. This will be the Lewis based structure. So this is actually the structure of the carbonyl group in gist. So whenever you add a nucleophile, suppose you are adding a nucleophile, which may be an organic base, which may be hydroxide ion or whatever, it can also be in alkoxide group also. In this case, this will attack this from here to the positive charge of the carbon. It attacks to the carbon, and this bond rips off like this, and you get a structure something like this. A carbon, oxygen negative. This is the group called B, and here you have put the nucleophile. So this is the flying wheel structure showing the tetrahedral structure. So naturally the symmetry changes from planar or trigonal planar to tetrahedral, and the hybridization of this group changes into sp3 from sp2. Now if we take a good example, the example will be addition of hydrogen cyanide or HCl to a carbonyl group. So you are having so the first step is how to get the Cl minus. Now when you consider this acid, you cannot use this acid for hydrogen for cyanidation. Why? Because it is a weak acid, ionizes to a very less extent, and so naturally you cannot get this nucleophile to a huge amount, which obviously slows the reaction. So to make the reaction fast, we go for step 1, which is the generation of Cn minus. How to get? You use an alkali here, NaOH or KOH, OH minus, H and Cn. So it takes up the Cn because this is delta plus, this is delta negative. So it is the reversible reaction, but mainly you get the forward one is the more preferred. So H2O plus Cn minus you have got. Now this is a very good nucleophile because it is resonance stabilized. So how this reacts with the carbonyl group? Suppose this is the carbonyl group you are possessing, delta negative, delta positive, and you have this Cn minus. So it comes and goes for an attack on the carbon of the carbonyl group. This bond rips off accordingly, and here you get a typical structure. Suppose two groups are there, A and B. So A, now carbon, oxygen negative, here you are having B. So this is above the plane because it is tetrahedral, nucleophile here. So this is the addition species. So this is step 2. Addition of nucleophile to carbonyl compounds or carbonyls. Now if you try, so this is the slow step or rate determining step. Now when you try to add some water which is acidulated or acidified water you are using, this is a reversible reaction and it is a fast reaction, and you get here also the product is more. So you get A, this is OH, here this is B, and this is the nucleophile. This is called cyanohydrin. The name of the species is cyanohydrin. Now if you consider a ketone, you mention it as ketone cyanohydrin. If this is an aldehyde, you write as aldehyde cyanohydrin. That is the nature. For example, if you are using acetone for the generation of its cyanohydrin, by this process, the product which you obtain is called acetone cyanohydrin. So if you try to go for an application, this can also be done in glucose. Suppose I am using this glucose. Just writing the formula in gist. To glucose, if you add HCN, HCN obviously OH also you are using here. OH, Cn minus, and then you are using H plus. What happens? CHOH whole 4, CH2OH, and to this you get COH, Cn, and here you get the H. This is what glucose cyanohydrin. This is an example, also an application and evidence. Why? Because this reaction is actually done to check whether glucose contains an aldehyde group, and the formation of cyanohydrin proves that glucose do contain the carbonyl group. So I am ending this topic here. I hope everything is clear. So goodbye.